Hello everyone, welcome to Brainy Equations. In today's video, we will tackle a tricky problem step by step. Let's begin. The question is minus 2 raised to the power x is equal to 2. We have to solve it for x. We have to find out the value of x. So first of all, we need to write it in terms of the log. So by definition, we can write log 2 is equal to x. Here we will get 2. We will write 2. So by the definition, it is not negative number. If it is negative number, it means that we will have no real solutions. So let's check. Let's start our question and check what type of roots we will get. So let's start our question. So this expression we can write it as minus 1 times 2 raised to the power x is equal to 2. So it is the first method, method 1. I will use two methods to solve this question. So it is the method 1 first of all. So 1 minus 1 times 2 raised to the power x is equal to 2. So we can write it as, we know that if we have a times b raised to the power x, we can write ax times bx. So we will use this rule here in this step. Minus 1 raised to the power x times 2 raised to the power x is equal to 2. So from here we can use the Euler's identity. It is very interesting identity. According to this identity, ei by plus 1 is equal to 0. Or if we take 1 from left side to right side, we can write I pi is equal to minus 1. We can plug in the value of minus 1. We can write this value in place of minus 1 here in the next step, and we will get here ei pi raised to the power x times 2 raised to the power x is equal to 2. Or we know that from the power rule, if ax raised to the power y, we can write x, we can multiply their powers. So we will use this rule here and we will get we can write it ei pi x times 2x is equal to 2. Apply the natural log on both sides of this equation. So what we will get, log of ei pi x times 2x parenthesis is equal to log of 2. So from another rule of log, if we have ln of a times b, log of a times b, we can write it as log of a plus log of b. So we will use this rule again here in our next step. Ln of ei pi x plus ln 2x is equal to ln 2. So we will use another very well-known identity here, that ln of a power p is equal to p ln of a. This p will come here. So in this expression, this will shift here and this will shift here. So our next step will become I pi x ln of e plus x ln of 2 is equal to ln of 2. So what we will do here, we know that ln of e is equal 1. So we can write in the next step I pi x plus x ln 2 is equal to ln 2. So here we can factor x easily, take x as common, and we will get I pi plus ln 2 is equal to ln of 2. Now here this part is constant and it involves one real part and the other one is imaginary part, and this is also a constant. So we can divide ln of 2 with I pi plus ln of 2, and we will get here x is equal to ln of 2 divided by I pi plus ln of 2. So it is our imaginary solution. As we discussed in the start of the video, that for this negative value we will have no real solution. So this solution is a imaginary solution because it involves imaginary number. So it was the first method in which we use the Euler's identity to solve this question, and you have seen maybe some students are not aware of this identity and they find it bit difficult. So we have another method. We can find the solution of x by using the second method. So in this method, minus 2 raised to the power x is equal to 2. We can write minus 1 times 2 raised to the power x is equal to 2. So we know that here I square is equal to minus 1. So we can plug in the value of minus 1 here and we will get I square dot 2 raised to the power x is equal to 2. Or we can write it as 2I square raised to the power x is equal to 2. We can take log on both sides, apply the log on both sides. You will get log 2I square raised to the power x is equal to log of 2. So from here we can write we know that the very common rule of the log, by the very common rule of the log, x log 2I square is equal to log 2. And here again we will apply a very common rule of log, that is log of 2 plus log of iota I square is equal to log of 2. Here we will write in the next step x log 2 plus this another rule of log 2 log of I is equal to log of 2. Here it is again constant and it is also constant. This constant involve one real part and the other one is imaginary part because of this I. So we can divide log of 2 with this part and we will get x is equal to log of 2 divided by log of 2 plus 2 log I. So again, where that involves the imaginary part and one real part and imaginary part, it is not a real solution, it is imaginary solution. So it is very interesting question. Here you used different common and very important rules of logarithms, and you have learned the Euler's identity too. This method is basically algebraical manipulation, but the other method is Euler's identity. If you found that method difficult, you can use this method, or if you feel easy, you can use that method. Both methods are nice method. I hope you have enjoyed it. Thanks for watching. If you found this video helpful, give it thumbs up and share it with someone who dreams big. So don't forget to subscribe for more solutions. See you in the next one. Bye.